Thanks a lot for coming, both to the Spinnaker Summit and to this talk. We have a huge amount of material, really, for an hour, and an hour's a long kind of conference talk anyway, because brains, whenever you say the word Kubernetes, brains start to fill up quite quickly, understandably, because there's a lot of complicated nonsense going on there. I'll try to speak slowly and yet go through a whole bunch of material as we go through CICD patterns. Black and white? Oh no, you just can't see from here. And so I'm the one on the left, in a much younger version, before I had the gray hair and my beard. My name's Andrew Phillips. Basically I've suffered all the way around the software development chain. I've told other people what to do. I've built the stuff. I've tried to deploy it, failed, all that kind of stuff. Do a bunch of open source work as well, although largely my open source contributions nowadays revolve around making slide decks and pitching things to conferences. I'll let Lars introduce himself.
Thanks, I'm Lars. I've been working on Spinnaker since before it was open sourced. Can you hear me? Everything good? Cool. I'm leading the open source Spinnaker team now, and I've been mostly working on the Kubernetes and the side of things. All right, I'll get out of your way, Andrew.
Good luck. Yes, I think I will need it. So I'll talk a little bit about what we're going to try to cover in the time here. But before I do that, let's have a little bit of a short sort of show of hands of Kubernetes expertise. Also a good exercise. Heard of Kubernetes? Hands up, keep them up. Using Kubernetes in tests, using Kubernetes in production, more than 2 years of Kubernetes experience, written your own CRD. All right, so yeah, okay, well, so interesting that there's an interesting mix between some of those. All right, so let's start by talking a little bit about what we're trying to cover. I think the first thing, introducing a topic that talks about CICD patterns for Kubernetes, is why are we even talking about it? Why is it an issue? I think that's hopefully a no-brainer to some, but I'd like to talk about some of the challenges we see, members in the community face, and obviously members outside the Spinnaker community. Members outside the Spinnaker community as well face. Then I'd like to start by talking a little bit about what we actually do in software delivery today. I think one of the anti-patterns is that we always try to reinvent the same wheel over and over again. And one of the challenges is figuring out what interesting things we can keep and what things we need to change. Which brings us up to the sort of third bullet point, which is, okay, what does Kubernetes actually add into the mix? Like, what's genuinely new about this technology and the ecosystem that we have to kind of incorporate into our mental model? And then once we understand that, both what we have and what we want to add, hopefully we can come up to a kind of set of patterns, a model that allows us to understand what we really want to do if we integrate Spinnaker or any other tool with Kubernetes. And then most importantly, because there's never a one-size-fits-all solution to software delivery, if we understand the concepts we're trying to implement, that gives us flexibility and freedom to deviate, if you like, from the straw man that we're going to present here in whatever direction makes most sense for your organization. This is the whole classic kind of agile in name only, DevOps in name only, Kubernetes in name only anti-pattern, where you follow some blog post because you read it, and then you have all the stickies and everybody stands up every morning if you're doing agile or whatever, but nobody really understands what the underlying concept is. And thus it makes it very hard for you to adapt the model to match what you actually need to do in your organization. And so, from my perspective, if you come out of here with an idea of what a good mental model is to have, and how you can potentially both implement this mental model in Spinnaker, but also how you can tweak it to match your own requirements, I think then we've done a really, really good job with this presentation. I should add, incidentally, that due to an unfortunate scheduling conflict, really you would all want to be in both this and the topic next door at the same time, where one of our colleagues from Google's SRE team is talking about many of the same lessons that have taken us to the way Google implements things internally, which are obviously somewhat similar to what the Kubernetes community is doing, but also interestingly different. And so I highly recommend, once the recordings are up, that you go through it, watch it at double speed. I think they only said they had like 35 minutes of talk, so you should be able to get through it pretty quickly. All right, so I kind of warmed up to this already. Basically, what's happening right now, and you could replace Kubernetes with any runtime. Whenever there's a new runtime, it was the same with mobile, it was the same with web, it was the same, I'm sure, with mainframe when they came out. Like, there's a lot of people looking at this new technology, and that includes a lot of Spinnaker users. So you have one vector of change. You're trying to understand a new technology. And then, of course, when people embark on one of these big adoptions, I want to adopt microservices, I want to do Agile, I want to do Kubernetes, that's often an opportunity companies take to clean up stuff and to do things better this time, especially around software delivery and CICD. Like I normally joke that software delivery is the kind of thing where everybody says, yeah, we know what we're doing right now isn't great, we'll do it better next time. And so the question is, then you've got two things that you want to do at the same time. You want to adopt Kubernetes, and you also want to clean up the old junk and cruft and duct tape and processes that you have to reboot every hour on cron and whatever. And so then you ask yourself the question, okay, how do we do this the right way? And so there's a bunch of challenges that stand in the way of doing this easily. First is that you have to understand this whole new technology that you're adopting. Kubernetes, the first time you look at it, especially something like Kubernetes, if you compare it to, say, Heroku or whatever, has an enormous amount of flexibility, complexity, and concepts that you have to try to wrap your head around. And then what happens in any new space, Kubernetes obviously the current example of that, because all these concepts are new and they're rapidly evolving, nobody's really figured it out yet, how to do it right. So, you can read 10 blog posts and they'll all give you 10 different opinions about what the right practice is, and depending on the age of the blog post, you can build these interesting timelines. And so, what you're faced with is you're faced with two challenges at the same time. You're trying to understand this new underlying runtime, and you're trying to figure out, in a world where best practices are still in flux, what the right way is to do it. So, of course, you can read tons of blog posts about GitOps or whatever, and try to figure out what they mean. But going from a blog post that says, hey, we have one developer and one repository and one Hello World application, to making this work across 15 development teams with 10 clusters and all kinds of regulated requirements and so on and so forth, is just really, really hard. And then, remembering that we shouldn't really always throw out the baby with the bathwater, integrating all this new stuff and this brave new world type concept with what we've actually learned about how to do software delivery over time is a sort of triple whammy challenge. And so obviously we hear this, no, that's going the wrong way. We hear about this regularly from people in the Spinnaker community, from people we speak to at Google, from people I run into at meetups and so on. And so one of the things we try to do is to think about this and provide some guidance in this space. So, sort of at a high level, and I sketched this out in the beginning, what we're trying to do here is as follows. Start out by talking about what are good practices that we actually want to retain, that we don't want to throw out, that we want to incorporate into what we're doing. Look at what Kubernetes adds and see what we need to incorporate into this existing model to build a first kind of straw man implementation of the CICD pipeline. Then understand what's really going on in that straw man, and build an appropriate mental model to understand why we've set things up the way they are. And that mental model gives us the capability to make trade-offs and tweak things around to make things better for our setup. So to give a really concrete example, this is very abstract. You'll see in the straw man model that we're basically using one environment repository with a couple of branches. And in many situations you might want to say, well, maybe an environment repository isn't the right thing. Maybe we want a blob store. Maybe we want one repository per environment, per cluster, or whatever. These are all trade-offs that are perfectly reasonable, but they're easier to make once you understand what the purpose is. And then, of course, the final part of the game is once you've built that mental model, once you've built a setup that works for your own environment, then you have to implement it. And unsurprisingly, at the Spinnaker Summit, we're going to be talking about implementing this with Spinnaker and a few things largely. But I think it's important to say that there are obviously plenty of other tools with which you could implement it. And being able to separate the tooling from the model gives you the ability to choose the right tooling for the task. I think a big anti-pattern, the classic cargo cult idea is that foo tool solves CI/CD for Kubernetes, ergo must implement foo tool. All right, doing pretty well, going at a good speed here. So let's go over some of the things that we want to retain. A lot of these are ancient, they should come as no surprise to anyone who kind of works professionally in the software delivery space. I'm setting up the first two largely as analogies. So the first one is that if you have, at some point in your software delivery pipeline, you have built a particular thing, you want to be in a state where you can always rebuild that thing, where you have all the ingredients that are necessary to do this. So this is a fairly common pattern, we do this all the time. But an interesting lesson that we've learned when we talk about building code, building binaries for instance, in theory, you should never have to store your actual runtime binaries. Because after all, if you have a fully reproducible build, you should always be able to rebuild that binary whenever you want. Of course, reality has taught us that this really isn't the case. Often it's really hard to reproduce builds from 10 years ago when the version of Maven that you were using doesn't exist or whatever. And so what we do in regular software delivery is we keep both the source and the stuff that we build from the source separately. And that's useful not just because it's better, but also because there is some information that we like to store about the derived artifact that just doesn't apply to the source. For instance, if you've done a vulnerability scan on a VM or a container image, that is a piece of data that applies to the binary, not the source code. This all sounds very, I'm setting this up because, of course, once you replace the word source with config or with manifests, you'll start to see some interesting analogies come out of this. We've always tried to minimize duplication. We all know the crazy, oh, I've got 5 Java properties files, dev.properties, staging.properties, act.properties, whatever, and they're all 95% the same. And so when I remember to add this new config flag, oh, I forgot to do it in staging, or hopefully not in production, etc., etc. So that's something we wanted to do. And I think that's a good thing to try to retain. And then I'll show a diagram that tries to make the next thing a bit more concrete. I think one useful thing to take away is that if you think of a sort of software delivery pipeline, a deployment process, it's a couple of things. It's both a technical process, like must update database before restarting server and so on, but it's also a business process. Must review, must approve before I can go to staging or production or whatever. And a lot of the times there's a sort of battle between declarative and imperative. I think that's a not very useful way of framing this. I think understanding that a business process is almost by definition imperative, and that the environment, the stuff you actually do in a single technical environment, you want to have robust and declarative is a really good model for that, is more useful. So I'll talk about the 4 processes in a second. I'd like to call out the final point, which is that if you think of a pipeline, typically you're thinking about making a change to code and then you roll that out through dev, test, staging, production, and so on. But there are definitely cases where you want to make changes that apply to one environment only. So I want to put my production log settings to trace or debug because I'm troubleshooting a problem. It seems kind of weird that we have to run an entire pipeline through 4 different environments just to set a production log setting. So we really want to be able to typically have both application updates and environment-specific updates, and we'd like to drive those through the same stuff. Let me just get to these this is what I was just talking about around the difference between the business process that typically goes across environments and what you're doing in each individual environment. And I think this is a nice framing to think about the difference between the declarative and imperative stuff. And of course for Kubernetes this is very relevant because there's a big emphasis on declarative. And I certainly think that what you do in an individual environment could be totally declarative. And this goes beyond Kubernetes. Terraform has tried to do this. Lots of tools have tried to do this in different spaces. But I think having a business process on top where you can say, I want to wait 3 days before I do my canary, whatever, that's really an imperative process. And I think we should try to retain that. So I've spoken about 4 processes that we really would like to combine. This is not Kubernetes specific, this is nothing new. But I think it's useful to remember them because very often when we talk about software delivery pipelines, we focus largely on the app update thing. I got that code repo somewhere, or maybe multiple if I'm doing a Spinnaker style microservice thing, and I push some change in there and I want to validate that and I want to ultimately roll it out to production. I already mentioned the second example, which is, well actually, if I'm only changing config in one environment, I probably don't want to run through this entire pipeline. And so those of you who have Helm in a repo and then orchestrate that will notice that it's non-trivial to do this if that's your kind of setup. So there's some trade-offs we have to set up here. But there's a few other things that are very common operationally that aren't really software delivery related, but that we definitely want to try to do with the data that we have. One is, when my environment goes down, I want to be able to recreate it, or I want to be able to revert my environment to a particular point in time. And that's often considered an operational thing, but I think if we can do it with the same data set, we're really in a good place. And then the final one is, oh, why is it not working in production? What's the difference between staging and production kind of thing, where I want to be able to diff the actual state of these environments, and you can take that a step further. I might not just want to diff them, I might also want to be able to stomp on any changes that show up, the classic puppet chef type model. And that's another process that's really operational, that's how people talk about it. But if we can do it from the same data set, I think we're in a good place. All right, what does Kubernetes add into the mix? I'll have to speed up here, after all. So I think the biggest and most important thing that Kubernetes adds into the mix, and again, it's not unique, but it's very much a focus of how you work with Kubernetes, is that there is this well-defined way of describing what an environment should look like. In-first code is nothing new. We've put like a description for what a server should look like in a repository for a long time. But if you think about in-first code works, you have essentially a template description of a server, and then you run that through Terraform or Deployment Manager or whatever, and now you have 1,000 servers. What you don't do typically is to store each of those 1,000 servers as a piece of individual config. Right, what we do with Kubernetes is different and interesting, where we say not only do we have like the raw template config, but as we create a staging environment or a production environment or something, it's worth storing that output YAML as a separate thing. And so this is what I call not in-first code, but environments as code. I think that's genuinely not technically novel, but definitely something that's new, that we bake this very explicitly into our software delivery setup. Another thing that's quite popular in the Kubernetes space, although I think it's debatable whether it's really the right choice, is this idea that once you have this environment config, you've got to figure out a way to make it real. And so, as with any of these approaches, you've got two main ways of doing it. You've got a push model. I'm going to look at the config and push it into the runtime. Or you've got a pull model, where you have something running in your runtime that consistently watches the config and not just applies it once, but tries to apply it on an ongoing basis. Right? We'll have some discussions about that. And then, of course, one thing Kubernetes does, which we have to figure out how to integrate, is it has some out-of-the-box support for certain types of deployments. And this is tricky because if you read a bunch of blog posts, you will get the idea that Kubernetes already solves deployments because it has the deployment object. But once you start digging into more complex use cases, multi-stage traffic rollouts being a classic example, it's actually really hard to get this right. And so having a good understanding of when the deployment object works and when it doesn't is an important kind of takeaway. I'm not going to mention the GitOps word very much, but I think just as an initial step, if you think about it as being a combination of environments as code, plus asynchronous watching of the code, and then using repositories as the kind of business process to define how to get from dev to test to staging to production, I think you have a very valuable deconstruction. And I think we're going to talk about each of these subcomponents a little bit individually. All right, so 2 slides or 3 slides ago we had this thing, which is the old-fashioned way of doing things. Here's the big difference, like this environments as code repository in the middle. I think largely speaking, that's the sort of state of the art that we have with Kubernetes today. And what's going on in the talk next door is our colleagues are describing how we use a very similar approach at Google, but for all kinds of technologies, not just Kubernetes. All right, moving on. Okay, so what did we say? Get an understanding of what's good practice, what we want to keep, what Kubernetes adds into the mix, and now let's start building a straw man for how this could look like in practice. And then we'll look at how some of these processes could work. So, setup here is a bit as follows. You've got 2 teams. They have a couple of environments. They've got their code, which is on master, and they've got some staging and production environments. And you have two clusters, but they could be namespaces. We're not going to talk a lot about what the best way is to split up a Kubernetes environment. So they're staging and production again, and they live in a separate repository. And again, it's a straw man. We might split this repo up. We might use totally different things for that. But here's a starting point. So I've deliberately chosen the way the teams set up their repos or set up what's in them in a slightly different way, because that's part of the trade-off that we can think about here. So in the first example, team 1 has some config definitions that they want in all environments in their master branch, so with their app code. Lars will talk a little bit about the difference between that and the second scenario. They have their service definition in there, presumably also mean that they want the service to be the same in all environments. But then for staging and production, they have different deployment definitions, right? Which is basically saying that I want to be able to tweak, say, the replicas, the amount of replicas in the replica set or whatever, separately, independently from each other. Team 2 has a slightly different setup, where they're using some entirely custom definition for their app. We'll look at that in a second. And then they have separate config for staging and production. And before we start, nobody's deployed anything. Our environment repository is empty because there's nothing going on. So let's look at what happens as an example when Team 1 tries to change their application. So they've got their service definition in their repo, and they decide to go from port 80 to 8080, and this is roughly what that could look like. Obviously, we can have long debates about the right way to template the bottom, but the point is that that environment placeholder is intended to be a template value. So this is a recognition that what you have in this master branch will change across your environments. So the first step is that we're going to the staging environment, and that means we generate from the template, we generate this full thing, like we take the config, and we take the environment, and this is roughly what it would look like, and if we want to, we can review and approve it, and then we say go, and we would deploy that, and so on and so forth. And when we're happy with that, we move on to production, which looks very similar, except that, of course, the environment is different now, because we're now deploying to production. So that would be a kind of two-phase, we do staging, then we do production, and as you notice, let me just go back here, as we do this, we end up with an environment repository that has two YAMLs, one per application, or one for each version in it. No, not for one for each version. We have the YAML for that application in each particular environment. Okay. So now application team 2 comes along, and they also want to make a change. And so notice here, one of the nice things about Kubernetes, if you think about this process that we just went through of, we talked about source code and compiled code, think of this as source config and compiled config. Like in my view, YAML is like assembly language. It's the really low level underlying definition. Of course you can get all your teams to program in assembly if you want to, but the nice thing about Kubernetes is that you could, just like, you could make this your equivalent of C++. You can use a higher level language to describe the config. And a lot of companies do that because it allows you to restrict what teams can do inside Kubernetes and apply standards and so on. So here, this team has chosen for a very limited kind of template format, which is just a version, some port number, and the image that they want to deploy. And that gets compiled, if you like, together with the staging config into a full deployment object with that image injected in, and so on and so forth. And then you obviously have the app version, which is specific. Now it's turning into two files. I'll show you why in a second. And then there's a second step, same again. You compile that source config and the custom settings into a YAML file and an environment-specific YAML, and then you deploy that out. So you now have two teams have a version of their application running, both in staging and in production. And now team 2 says, uh-oh, we have a production issue. We would like to change the config so that our debug, our trace logging, or our logging goes from info to trace, for example. So if we look back at team 1, where the configuration only lives in master, they'd be stuck effectively with having to say, I'm going to change the variable for this thing, because you want different debug settings for different environments, but I have to run the full pipeline. I have to go to staging, basically do a no-op deployment. Kubernetes is kind of nice about that. And then I have to go to production. But what I can do with this setup here is the second team they can make a change to this config map which lives in their production branch, and that can trigger a different type of automation which doesn't try to run the whole pipeline at all. It goes directly into the production environment and says, I'm going to change the config over there. Notice also that you can trigger this config change without ever having to build a new version of your application. So one of the problems with running an app pipeline every time is you typically have to run through a full container build, which can take a really long time. And to update your container just to make a config settings change in one environment is a real weirdness. Right, let's speed up even more. So, Lars, I'm going to leave Lars time for his demo. I recognize there's a lot of dense material in here, so I'm happy to talk at one of our office hours or whatever. What have we just shown? What are the key pieces of this straw man? And so I think the first is that we have the same way we have source code and config code and compiled code in a regular pipeline. Here we have source config and compiled config. And we store them both separately from each other. In this model, we have one repository per team, where the team stores their stuff, the stuff they control, but the environments, if you like, the compiled config, lives in a shared place, because if you have each team having their own environment, then understanding the state of your environment requires joining 50 repos together, which is a really hard operation. I've tended to use branches here versus different repositories or folders, because branches have their separate commit history, so you're not mixing commits from staging versus production, for example. But it's much easier to compare branches than comparing repos, for instance. There are problems too, because especially around access control and so on, so we can get into those a little bit later. And then I'll let Lars talk about the next one, which is kind of interesting, which is if you put your config in your application repository, you don't have that much duplication, because you just have a placeholder somewhere that changes per environment. If you have them on each branch, as we do in the case of Team 2 here, those things are very duplication-y. There's a lot of duplication in those, which is not great. Remember we said the best practice is to try to reduce duplication? So there's a trade-off here between, do I need to change the setting independently, or can I get away with just running an entire pipeline if I want to make this change? And then the final one is that, again, as in the Team 2 case, I think it's totally legitimate to think about not using raw Kubernetes YAML as the level of abstraction. Of course, there's different ways to implement that. CRDs might be one you want to do. Personally, I think having effectively your parser, which is what a CRD controller is, live in your runtime, that's pretty icky from my perspective. But anyway, we'll talk about that a little more. And I will hand over to Lars.
Cool, thanks Andrew. First, I'll go into a little bit of detail about how we actually reason about these changes, separate from what Andrew was talking about, then relate that back to his 4 related processes, the ones he was showing us, and then demo what these actually look like in Spinnaker. Some of it's not exactly where we want it to be in Spinnaker. There's features we still have to add, so we'll explain around that. And then finally, demonstrate what this could look like in your environments at home. So to begin with, the typical push something to production pipeline simply looks like you do CI, which is you build and validate, and then CD does deploy to staging and promotion to prod. Often we find it's an oversimplification. There's actually more ways your changes can make it into production, and we'll take a look at this across sorry, 2 dimensions here. So luckily these dimensions are small, so we can draw a nice little quadrant. So we have changes that are dependent on the version of the application they're in, and independent from the version, as well as changes that are dependent on the environment they're in, and changes that are independent from their environment. So the first kind, which is arguably the most common, is you make a code change, you promote it all the way through to production, same with a config change, and ultimately all your environments look the same, but the change actually is dependent on the version of the application. If you roll forward or back, that change appears or disappears. Similarly, we have changes. We make a change, like Andrew was saying, maybe we add debug logging to staging. It's a change we make only to one environment. And again, it's something that actually depends on the version of the application that we're running. If you roll forward or back, the change appears or disappears. But we're making this only to one environment at a time. Where it gets a little weird is where we have changes that are actually independent from the version of the application that they're running in. So say, for example, your database management team rotates their credentials every week. Tomorrow they're rotating credentials. You make a change, you code it, or you couple it to the version of your application. If you roll back to today's code in 2 days, you'll be in trouble because the credentials stop working. So you also have these kinds of changes which you have to be aware of, which actually aren't coupled with the version of your application. This last quadrant is a bit of a weird one, but we have it in here. So say, for example, you have a jar license dependency that has to be you found is in violation of the code you're running, and you have to update this across all environments and all versions of the code you want to run. So a brief recap here, Andrew's 4 related processes. We'll actually dive into these in detail here in the form of some Spinnaker pipelines. So we have a little application here. We're running
Tiny Go app, we have some manifests. These have overrides for environments. We have a source directory, which has a little Go file in it. And we're managing the updates with some Spinnaker pipelines. So let's see. There we go. So here's Spinnaker, and like Andrew was saying, we're not going to go into detail about how we actually want to structure staging versus production. Here we're using namespaces. We have one Kubernetes cluster, it could very well be many that are split across environments. But here you see you have a deployment object in staging, a deployment object in production, and they're both running what looks like to be the same version of our application. We also have a publicly reachable endpoint. Looks like right now the background's green. It's kind of hard to read. But we have some environment-only configuration and some application-level configuration. So first thing we have here is a deploy to staging pipeline. We jump into the configuration. We say we can trigger either off changes in GCS, which is where we store our manifests, or changes in GCR, which is where we store our images. And if an artifact from one of those doesn't arrive, we use whatever arrived in the prior execution of this pipeline. Looks like it kicked off. First thing we do is we bake our staging manifest, which means we say, okay, I'm going to bake a Helm chart that has some templates in there, and we're going to override it with some staging specific values. These are things that only appear in your staging environment. And we deploy, we validate, and we do a snapshot operation where we actually push this back into a repo. This looks okay. This is going to run and actually push those manifests up into this bucket that we have right here. So let's see. So here we have a deploy folder, and again, this is an implementation detail of how these things are structured, and we push, as this finishes, a new version of this manifest file into this bucket right here. So far, not very interesting, but the pipeline will here should continue quickly. Let's see. Oh, okay. Looks like it's taking its time. As that goes, let's talk about the production pipeline. So this one's actually a little more interesting. So this one, because we're trying to push something and make it the same across all environments, is triggered off of our staging pipeline. So here we say, whatever comes from the deploy to staging pipeline, take that, and from that also inherit the artifacts that you consume there, minus the staging specific values. So we take that same Helm file, that Helm chart that we baked, and we take that same image, the same one that we deployed to staging, and we use those as inputs to this, this pipeline that's going to run right here. First thing we do is we bake again. It looks very similar. But now we actually do something interesting, and we're going to run a manual diff of what we have running in production and what we're about to deploy to production. This right here, it's a bit of a hack. We're running a job. We want to make this better. We actually want to do a three-way diff between what you have running, what you're trying to apply, and what was applied the last time that this pipeline ran. So it looks like this is running, and it's going to actually ask us to look at that diff. We have a console output here. And some of the stuff in here is noise because Spinnaker applies annotations. But as you refine this, you'll hopefully only see things change that you want it to change. So if you made a change only to the production environment, you should see like a config level change, or you should see the Docker digest change on that image right there. So let's say this looks okay. So we made a change across all environments. Let's talk about making a change to one environment only. And we're going to use that example we had earlier about database credentials being rotated. So let's run update production. And this should automatically trigger that update to production environment pipeline. And this, again, is not very interesting as a pipeline in and of itself. All that really does is listen to changes for that file in that GCS bucket. And when it arrives, it deploys it as a config map. So like Andrew was saying here, we also have like an environment backup or restore. It's typically what you would use for a rollback, but it's also really handy for things like spinning up a new cluster and saying, I have a known good version, I want to start running this again. So let's take a look here. We have this restore production from backup pipeline. And again, inherently, the pipeline isn't very interesting, but what it's doing here, let's use an old revision. We could say, I want to restore from GCS revision XYZ. And again, this is something that we can service better in Spinnaker, maybe make a dropdown available, or have a better integration either with Git where you're storing your manifests, or with GCS where you're storing your manifests, and allow you to say, okay, I want to roll back. And all that's doing is it's taking those same manifests that snapshotted after it ran the production pipeline, and now reapplying them only to the production environment. The last one here Like Andrew was saying, we also have, we sort of already demoed this by showing the diff between what was running in production and what we're about to deploy. We can apply that same technique to actual diffs between various environments. So we have a pipeline in here which, again, does a manual diff by running a job, but it's something that we want to do better in Spinnaker, and it kicks off that job for us. And let's see what it says. And here we can see the actual differences between the production and staging environments. So we have debug logging and staging, info logging and production. We're deployed to different locations as Spinnaker sees it. Namespaces are different, and the changes continue here. Let's talk briefly about the mental model that you want to have. So like Andrew was saying, it's really the app repo that's driving the deployment. This is the thing that has your source code, it has potentially your manifests, or your templates, however you're storing those, and it's the environment repo that's snapshotting the cluster state. The little analogy here is source code in GitHub is the built Docker image in the registry, in the same way that the template in the app repo that you have stored is the manifest in your environment repo. The environment repo really is just a checkpoint in time. Your cluster can and will evolve. It changes in a couple of different ways. The most obvious one is you have Kubernetes always applying changes when you submit manifests. So for example, if you have Istio enabled and you deploy something, you will immediately get a sidecar attached to that. There's always changes being made by Kubernetes. The other one is if you have a multi-stage rollout that's being orchestrated by something that's not Kubernetes, you're going to have multiple intermediate states that have to be captured somehow in that environment repo. So for example, if you deploy a canary, when that canary is there briefly collecting traffic, that might show up in your environment repo. Similarly, and something that you have to ask yourself some questions about is rollback and environment restore really doesn't have like a silver bullet, so to speak. It's very possible that your relative success metric isn't successful, and when you go to rollback, some things can still go wrong. The last thing we point out here is something that's kind of tricky for Spinnaker and tools like it, which is where if you're always submitting a subset of your manifests, it's not always clear to the tool if a manifest was deleted or if you're simply not making a change to it. And when it gets deployed, that's not necessarily a problem, but when you go to restore and you've actually deleted something but the tool never knew to delete it in the first place, only when you go to restore does that thing actually show up as broken. Okay, so again, like Andrew was saying, you do want to build some level of abstraction on top of Kubernetes. The big question is really how much do you need to abstract? And if you build an abstraction, what does that look like? Is it a template? Is it something like a Helm chart? Is it a CRD, which is like a first class way to build third-party extensions in Kubernetes? Or is it in the automation tool, which is something that the Spinnaker Review 1 provider relied on very heavily? If you do templating, there's two general approaches that we see. The first one is like a token replacement, which is Helm and the Go substitution. Or do you use overrides, meaning do you have a template that you submit, and then you have a series of paths and values that you override in there. Again, it's something we were alluding to earlier. If you do have this environment repo, when do you actually publish to it? Is it after Kubernetes says everything's okay? Is it after you've done a very long rollout and everything looks good? Do you have Canary that's gating these publishes to the environment repo? There's a number of ways to do this, and it's really up to you to structure when and where to publish to that repo. Next question. So how do you actually structure the repos that you publish to? If you go and try and implement a very vanilla GitOps style approach, you'll realize quickly that it can be kind of painful in GitHub with the access control it provides to make sure that only certain users can read from certain environments and certain branches. In this case, it's actually many times easier to use something like a blob store for the environment repo, but that's something you have to ask yourself. The last thing we point out here is we often see people turn towards Helm for their templating. Helm as a tool was really built for distributing sets of manifests. It's not necessarily made for deploying changes over and over again to a set of manifests that you're continually developing against. But again, the templating in Helm is very powerful, and that's why we support it in Spinnaker in the first place. So just to recap, So figure out what your storage implementation is for that end repo. Do you use GCS bucket with folders? Do you use a bunch of GitHub repos with branches or with different orgs or different repositories? Once you know how you're structuring that, figure out what's the kind of abstraction that you want to expose your developers to. Are they overriding things in templates? Are they writing out CRDs by hand? Or are they relying on their automation tool to provide that abstraction for them? Here, and it's obviously the Spinnaker plug, is choose the flexible automation tool for your business practice. It's something that provides you with the deployment needs that you have. And then going back to what we were saying earlier, is figure out when and where you actually have a successful deployment that you can store and snapshot and restore to later when you publish to that environment repo. We showcased 4 processes. These aren't all necessary. If you have a very simple application that CICD, build and validate, deploy to staging, deploy to production is sometimes all you need. But as your needs grow more complex, it's good to have and understand how these work so you can implement these yourself. Cool, and that's it. If you want to actually try this out, so the code we're showing here, it's all in a big tarball. We can send it to you. You can play with it, play with the Spinnaker pipelines, get a sense for how they work. Just ping us for a sample. We have a SIG Kubernetes channel on Slack, which is pretty active and talks more about how to use the Kubernetes provider rather than asking more of the setup-related questions. We have a Spinnaker Kubernetes SIG that talks about these things. We're meeting tomorrow during the Kubernetes office hours if anyone's interested. And then finally, if you want, suggest new Spinnaker features that would make this easier for you.